Introduction to vectors. Here is question number 5, which is similar to the previous question. It says Peter drove south at the speed of 60 kilometers per hour for 2 hours and then 80 kilometers west and then 80 kilometers west. So part A is draw geometric vector to represent the displacement. Part B is calculate magnitude of the displacement. And C is calculate the bearing of Peter's car to the nearest degree, right? So we are assuming that he is driving a car, and then answer these questions, right? So take your time, but remember, geometric vector is represented by an arrow, and which we call directed line segment, and length of this line segment should be proportional to the magnitude of the vector, correct? And it should direct in the direction where the vector directs. So that is kind of important. So making a scale is very crucial for this question, right? And how will you find the magnitude? Once you make a scale and sketch it, then use Pythagorean theorem or the distance formula to get the magnitude, right? Try to solve the question and then look into my suggestion, okay? So here is my suggestion. So let's read the problem once again. Peter drove south at the speed of 60 kilometers per hour for 2 hours and then 80 kilometers west. So to solve this problem, let's make our grid, right? And define, x and y scale, right? So let's say 80 kilometers we have to represent, and then 60 kilometers per hour for 2 hours. So these are the things, right? So let's work out distance. Now from the first part, we know he drove south at the speed of 60 kilometers per hour for 2 hours. That means in south direction, we have to go 2 times 60. So first thing, he drove 60 plus 60, which is 120 kilometers south, right? So, and then we are driving 80 kilometers west. So I think a good scale is to use 40 as a scale, right? So that will help. So let's use a scale of 40. Like this. So when we use a scale of 40, let's say, then, so we are saying the scale is 40 units. So that represents our scale. And here 60 kilometers per hour for 2 hours. That means south we need to go 60 kilometers times 2 and becomes 120 kilometers, and the direction is south. So 40, 40 and 40 makes 120. So that becomes your geometric vector. So as you can see, we have a scale here. Arrow, starting point, is the tail, that is the head. So that's the geometric vector which represents first part of the problem. And then 80 kilometers west. So west means this direction, right? So let's go 40 and 40, correct? So that becomes 80 kilometers. So here it is. So 40 and 40. Scale is important. So let's go like this. Going west. So that is 80 kilometers going west. So we have north here. Let me write in a different ink. We have north here. Now it is assumed east-west. You may not write always. And that gives us 120 kilometers. And this is 80 kilometers. So that is draw a geometric vector to represent the displacement, right? So that is your displacement. Second part is calculate magnitude of the displacement. Now magnitude of the displacement actually is from initial starting point to the final. So when you add them up, what do you get? you get this final, correct? Let me draw this final. So from here to here, that is what you get. So let me draw a line with an arrow showing this. So that becomes final, right? So if this is the starting point O, let's say this is A and B, then OB is your final, right? See how we get it. O plus OA plus A to B is equals to O to B. Do you see that? So that is our final, and that's the vector OB. Now for this vector, we need to give magnitude. How can you find the magnitude for this? To find magnitude, you know this is 90 degrees, right, in this case? Now you can say A square plus B square will give you this side, and square root of that, correct? That gives you the answer. So the final displacement is, let's say displacement D is, we are talking about magnitude at present, is equals to square root of 120 square plus 80 square root, correct? So you can use your calculator, calculate the answer, correct? But that is your answer. Now the next part is calculate the bearing of Peter's car to the nearest degree, right? Now what is bearing? Bearing is angle from north, right? Angle from north. Now from north, that is the bearing. So you need to find this angle. So one way to find this angle is, you can calculate this angle. Let's call this angle as theta. So what will theta be? So we say tan theta is equal to opposite over adjacent side. So that means 80 over 120, right? So theta is going to be equals to tan inverse of 80 over 120 degrees, correct? So that is what tan theta is. Now we can use your calculator and find tan inverse within bracket 80 divided by 120 bracket close equal to 33.69. So we get here 33.69 round to nearest degree will give us approximately 34 degrees, right? So this angle for us is 34 degrees. But we have to give angle from the north. And so angle will be 180 plus 34. So our answer is 180 degrees plus 34. So that's the bearing angle we are talking about, right? So for 8 plus 3, 11, 214 degrees is the bearing angle, right? So the bearing angle is 214 degrees, right? Always when you write bearing angle, you should write 3 digits here. What degree sign? It is measured in degree. So what is the bearing angle of north? Bearing angle of north is 0, 0, 0 degrees. Don't forget that, okay? And bearing angle of west will be 270 degrees, right? And east, 0, 90 degrees. Don't forget this 0, okay? And that you know is 180 degrees. So that is how you get to know all this. So it was kind of a review for whatever we have done so far. And I hope you can recollect all the things. And now we'll move on to the next topic and we'll discuss about opposite vectors. So those things soon we'll get into vector algebra then. Okay? Thanks and all the best.